Hi, hello, welcome back to Homeschool Class 10 Mathematics Revision with Radhika Ma'am. Today our topic is Introduction to Trigonometry, third exercise. This is your last exercise, exercise 8.3. Before starting exercise, we need to remember three identities. That is sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. If you know these three identities, you can rewrite these three in the form of 9 identities. Right? First, remember these three carefully. Sin square theta plus cos square theta is 1. 1 plus tan square theta, secant square theta. 1 plus cot square theta is cosecant square theta. If you need sin square theta, cos square theta send other side is equal to 1 minus cos square theta. Suppose if you need cos square theta, transpose sin square theta other side, that makes 1 minus sin square theta. Now next one. 1 plus tan square theta is equal to secant square theta. If I want tan square theta, I can write it as secant square theta minus 1 or secant square theta minus tan square theta is equal to 1. Okay. Now the third identity is 1 plus cot square theta is equal to cosecant square theta. Cot square theta is equal to cosecant square theta minus 1. Another one, cosecant square theta minus cot square theta is equal to 1. So to frame these 9, first you remember three identities carefully. Sin square theta plus cos square theta equal to 1. 1 plus tan square theta equal to secant square theta. 1 plus cot square theta equal to cosecant square theta. Exercise 8.3, first problem. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Express sin A in terms of cot A. Observe sin formula. Anyway you can see cot. No, I cannot. So, sin is reciprocal of cosecant, right? So, anywhere in cosecant formula can you see cot? Yes. That one only you take. What I am going to take? Cosecant square A. Here letter you have A. So, take A is equal to 1 plus cot square A. I want only cosecant A. So, remove that square. Then what happens? Apply square root plus or minus square root 1 plus cot square A. Okay. Now, sin A in terms of cot A. First I will write sin A is nothing but 1 by cosecant A. That is 1 by plus or minus square root of 1 plus cot square A. Sin A in terms of cot A completed. And the next one is secant A. Secant A, how can I write? Observe secant and cot. Do you have anything? Yes. I have here tan. Tan is nothing but 1 by cot, right? So take that one only. We know secant square A is equal to 1 plus tan square A. That is tan square A I can write it as 1 by cot square A. Secant square A is this one. Now do LCM. Secant square A is equal to cot square A plus 1 by cot square A. Secant A is equal to plus or minus square root cot square A plus 1 by cot square A. So here when I split the root, square root of cot square A plus 1 by square root of cot square A is nothing but cot A. So write that one only. Therefore, secant A is equal to plus or minus square root of cot square A plus 1 by cot A. So, secant A in terms of cot A written. And the next one is tan A. Tan A directly you can write tan A is equal to 1 by cot A. That's it. Second one, write all the trigonometric ratios of angle A in terms of secant A. Now write all the trigonometric ratios in terms of secant A. So first let me start with sin A. Sin A secant A. How can I get? Secant A is nothing but 1 by cos A. So sin A cos A I will get in first identity. So write that one only. Sin square A plus cos square A is equal to 1, I know. Then sin square A is equal to 1 minus cos square A, that is 1 minus cos square A, I can write it as 1 by secant square A. Okay, do LCM. Sin square A is equal to secant square A minus 1 by secant square A. Now sin A square apply other side square root plus or minus secant square A minus 1 by secant square A. Split the root. Sin A is equal to plus or minus square root of secant square A minus 1 whole divided by this secant square A square root. Square and root will be cancelled and you are left with secant A. Sin A in terms of secant A completed. Then what about cos A? Cos A is nothing but 1 by secant A. Next coming to tan. Tan A secant A direct relation you have. We know tan square A is equal to secant square A minus 1. Tan A is equal to plus or minus square root of secant square A minus 1. That's it. Tan A in terms of secant A. Next, cosecant A in terms of secant A. Cosecant A is nothing but 1 by sin A. Already you got sin A in terms of secant A. Write that one only. Cosecant A is equal to 1 by sin A. What we got sin A here? Write as it is 1 divided by plus or minus square root of secant square A minus 1 by secant A. Now bring this to the numerator, that means do the reciprocal and multiply to 1. That is secant A divided by plus or minus square root of secant square A minus 1. Cosecant A in terms of secant A. Next what you have? Secant A in terms of secant A as it is, no need of writing. And next cot A. What is cot A? Cot A is nothing but 1 by tan A. Right? Tan A we already got something. Write that one only. 1 by plus or minus square root of secant square A minus 1. That's it. Observe carefully how I have written these all using the identities. Same manner they can change the terms. Suppose write sin A cos A in terms of tan A they may ask, in terms of cosecant A they may ask. Just observe the identities carefully and try to write this. Third main, choose the correct option and justify your answer. First one in it, 9 secant square A minus 9 tan square A is equal to. Let us solve this one. 9 secant square A minus 9 tan square A. From these two, 9 is common. So take out secant square A minus tan square A. And we know from the identity, what is that? Second identity, 1 plus tan square A is equal to secant square A. Whereas secant square A minus tan square A is nothing but 1. So write that one. 9 into 1 value is 9. So which is your right answer? Option B, 9 is your answer. Second one, 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta is equal to. Let us start solving this. Tan theta can be written as sin theta by cos theta. Secant theta can be written as 1 by cos theta. And cot theta can be written as cos theta by sin theta. Minus cosecant theta can be written as 1 by sin theta. Okay, do LCM. Cos theta. See here 1 you have 1 cos theta LCM is cos theta. Multiply cos theta for this one, that is cos theta plus sin theta plus 1 into same manner sin theta numerator sin theta plus cos theta minus 1. Observe carefully here children. I think it is looking like sin theta plus cos theta. Here also sin theta plus cos theta. So if I consider this as A and this as A plus B, A minus B. So write that one only. I will write sin theta plus cos theta. What is A plus B into A minus B? A square minus B square. Numerators if you multiply A plus B into A minus B, you are going to get A square minus B square. Denominator cos theta into sin theta. Right. Now again I can see some formula A plus B whole square. That is A square plus 2AB plus B square. Write that. Sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 whole square is 1 by cos theta sin theta. Right? From the first identity, what do we know? Sin square theta plus cos square theta is 1. Write that one. 1 plus, this full set is 1. So 1 plus 2 sin theta cos theta minus 1 by cos theta into sin theta. Minus 1 plus 1 will be cancelled. Next 2 sin theta cos theta by cos theta into sin theta. Sin theta into cos theta into sin theta is same. So cancel this. You are left with the answer 2. Check for this option. It is option C is your answer. Third one, secant A plus tan A into 1 minus sin A. Let us solve here. Secant A can be written as 1 by cos A. Tan A can be written as sin A by cos A into 1 minus sin A. Now do LCM this. Cos A denominator 1 plus sin A into 1 minus sin A. Again observe carefully, this one is multiplied for the numerator. A plus B, A minus B format there. That is A square minus B square. Sin A whole square is sin square A by cos A. We know from the identities 1 minus sin square A. 1 whole square will be 1 no. 1 minus sin square A is cos square A. Cos square A by cos A. So 1 cos A will be cancelled. Your answer is cos A. Search for the answer. Option D. Fourth one, 1 plus tan square A by 1 plus cot square A is equal to. By identities, 1 plus tan square A is secant square A and 1 plus cot square A is cosecant square A. Secant square A is nothing but 1 by cos square A and cosecant square A is 1 by sin square A. Do reciprocal. 1 by cos square A into sin square A by 1. 1 into sin square A is sin square A and cos square A into 1 is cos square A. So this will be sin A by cos A whole square. That is nothing but tan A whole square. That is tan square A is your answer. Check for the option. This is also option D. Okay, with this we complete our third main. Fourth main, prove the following identities where the angles involved are acute angles for which the expressions are defined. See, in this trigonometric chapter, this fourth main, which contains 10 problems, are very important for annual exam. Listen carefully this main, because one question will occur guarantee in your annual examination, either for 4 marks or for 3 marks. Right? First one in it. Cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Using identities, we need to prove this one. First, let me consider LHS. Left hand side, cosecant theta minus cot theta whole square. These problems, considering LHS, you can prove RHS, or considering RHS, prove it as LHS, or both you drag. That means LHS, you will get one answer. RHS, you will get one answer. If both are equal, then you can say that they are equal, hence it is proved. Okay. In this problem, I am considering left hand side first and I will try to solve. Cosecant theta can be written as 1 by sin theta minus cot theta can be written as cos theta by sin theta. Children, write in the simplest form these are all. Okay, and then try to solve. Do LCM. Sin theta 1 minus cos theta whole square. Okay, now split whole square. 1 minus cos theta whole square by sin theta whole square. I can write it as sin square theta. Now once observe your right hand side, what you have? 1 minus cos theta by 1 plus cos theta. Observe, I got already here 1 minus cos theta, but one more 1 minus cos theta there. So split like that. 1 minus cos theta means a minus b whole square. I'll write it as a minus b into a minus b. Okay. Now sin square theta. We know the identity. What is that identity? Sin square theta is equal to 1 minus cos square theta. Write that. 1 minus cos square theta. A square minus b square. 1 square is 1 minus cos theta whole square. Apply a square minus b square formula. That will be 1 minus cos theta into 1 minus cos theta whole divided by 1 plus cos theta into 1 minus cos theta. This side you can write a square minus b square is equal to a plus b into a minus b. We have used this one. Right? Now what happens? 1 minus cos theta, 1 minus cos theta cancel. That equal to 1 minus cos theta by 1 plus cos theta. Observe RHS. It is already proved. Therefore, this equal to RHS. LHS is equal to RHS. Rewrite the question again. And say hence it is proved. Yes, very simple. Understand carefully. And your second problem, cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 secant A. Consider LHS part, that is cos A by 1 plus sin A plus 1 plus sin A by cos A. Okay. Further, I cannot simplify this one, so I need to do now LCM. LCM for both the denominators 1 plus sin A and cos A is, right, cos A into 1 plus sin A. Here denominator 1 plus sin A there, so multiply for the numerator cos A. That means cos A into cos A will be cos square A. Same manner here cos A there. 1 plus sin A multiply for the numerator. That becomes 1 plus sin A whole square. Again you can see an identity, that is A plus B whole square. Split that one. Cos square A plus A square plus 2AB, 2 into 1 into sin A or 2 sin A you can write, plus sin square A whole divided by cos A into 1 plus sin A. Don't remove brackets children, as it is try to keep, because our answer should be 2 secant A. Secant A means 1 by cos A should be there. That means this term will be there. This will be cancelled, I think. Okay. Now, what is cos square theta plus sin square theta? 1. Substitute that one. 1 plus 1 whole square is 1 plus 2 sin A by cos A into 1 plus sin A. That will be 1 plus 1 is 2, 2 plus 2 sin A by cos A into 1 plus sin A. In numerator, 2 is common. 2 plus 2 sin A, 2 is common. So take out common. 1 plus sin A by cos A into 1 plus sin A. 1 plus sin A, 1 plus sin A cancel. 2 by cos A is left. 2 into 1 by cos A is nothing but secant A. Therefore, LHS is equal to RHS. Rewrite the question again and say hence it is proved. Very important question. So, understand carefully and try to solve. Third problem. This is very important problem. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta cosecant theta. Right. Now, similarly you take consider left hand side, that is LHS. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Tan theta can be written as sin theta by cos theta. In your hint also they have given, express the terms in the form of sin theta and cos theta. Now 1 minus cot theta can be written as cos theta by sin theta plus cot theta, write it as cos theta by sin theta whole divided by 1 minus tan theta can be written as sin theta by cos theta. Now denominators do LCM. Sin theta by cos theta whole divided by 1 and sin theta, LCM is sin theta. Multiply for 1 the sin theta minus cos theta plus cos theta by sin theta divided by, do your LCM, cos theta, and again cos theta into 1 will be cos theta minus sin theta. Okay. Now the denominator what you have, do the reciprocal and multiply for this. That is sin theta by cos theta into sin theta by sin theta minus cos theta plus same manner cos theta by sin theta into, do the reciprocal, cos theta by cos theta minus sin theta. Okay. Now numerators multiply children. Sin theta into sin theta will be sin square theta by cos theta into sin theta minus cos theta. Okay. And what you have sin in middle? Plus cos theta into cos theta will be cos square theta by sin theta into cos theta minus sin theta. Okay. Now we need to do LCM for these two. Observe carefully. Sin theta, cos theta. Okay. Now what about the sin theta minus cos theta and cos theta minus sin theta? Are those two different? Can we make them same? Yes, we can make. Most of the children will be stopping the problem here itself. Don't be panic, children. This is the step you should remember carefully. Here, if I take a negative sign common, that means sin square theta by cos theta into sin theta minus cos theta plus cos square theta by sin theta into, look here children, this plus cos theta and minus sin theta there. Full bracket, take a negative sign common. And I am writing that negative sign here. Okay. So if I take minus common for plus cos theta, it is left with minus cos theta. And minus sin theta becomes plus sin theta. Okay. Now this minus multiplied to this plus. So I am doing in one step. You people can do one more step. Minus into plus minus. Now observe sin theta minus cos theta. Sin theta minus cos theta brackets become same. Do the LCM. Sin theta cos theta into sin theta minus cos theta. Now in this set, cos theta, sin theta minus sin cos theta there. So sin theta is missing. So multiply for this numerator sin theta. And here cos theta is missing. So multiply cos theta. That becomes sin square theta into sin theta will be sin cube theta minus cos cube theta. Okay. Again you remember a formula. What is that formula? A cube minus B cube is equal to A minus B into A square plus AB plus B square. Okay, write that in the form of numerator. So what I can write, A value is sin theta, B value is cos theta. Sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. So I have written AB here children, no problem, nothing will happen. By sin theta into cos theta into sin theta minus cos theta. Okay. Now sin theta minus cos theta, sin theta minus cos theta cancel. And sin square theta plus cos square theta by identity, what do you know? 1. So write that one. 1 plus sin theta cos theta by sin theta cos theta. Split the denominator for both the numerators. 1 by sin theta cos theta plus sin theta cos theta by sin theta cos theta. Now this one will be cancelled and you are left with 1, and this becomes, split the numerator, 1 by sin theta into 1 by cos theta. That becomes 1 by sin theta is cosec theta into 1 by cos theta is secant theta plus 1. Observe your RHS, 1 plus secant theta cosecant theta. That only we got 1 plus secant theta into cosecant theta is equal to RHS. Therefore, rewrite the question and say hence it is proved. This is very important problem in this main. Okay, don't be panic. Most of the children will do mistake here itself. Check while you are doing. Fourth one, 1 plus secant A by secant A equal to sin square A by 1 minus cos A. In brackets you can see there, simplify LHS and RHS separately. So as usual, let us consider left hand side first. 1 plus secant A by secant A. Secant A means 1 by cos A. Write that one only. Whole divided by secant A is 1 by cos A. Do LCM for the numerator. 1 and cos A, LCM is cos A. And here multiply cos A for 1. Cos A plus 1. Whole divided by 1 by cos A. Cos A cancel. You are left with cos A plus 1 you can write, or 1 plus cos A. Mark this first equation. And now consider right hand side. What do you have? Sin square A by 1 minus cos A. Sin square theta, what is the formula? 1 minus cos square theta. That only right here. We know sin square theta is nothing but 1 minus cos square A. 1 minus cos square A by 1 minus cos A. Again I can see A square minus B square formula. That is A square minus B square is equal to A plus B into A minus B. You may think, where is A square? 1 square is nothing but 1. So 1 there also you can imagine it as a 1 square. Now A square minus B square. 1 plus cos A into 1 minus cos A whole divided by 1 minus cos A. So what happens here? 1 minus cos A, 1 minus cos A cancel. You are left with 1 plus cos A. So observe here, cos A plus 1 or 1 plus cos A both are same. So mark this 2 and write from equation 1 and 2, LHS is equal to RHS, and rewrite the question and say it is, hence it is proved. Fourth problem, cos A minus sin A plus 1 by cos A plus sin A minus 1 equal to cosecant A plus cot A. Using identity, cosecant square A is equal to 1 plus cot square A. Prove this problem. So using that identity we need to prove. Observe LHS cos A sin A, already in a simplified form it is there. So what I have to do? First take down, consider LHS left hand side, cos A minus sin A plus 1 by cos A plus sin A minus 1. Next what I need to do? Observe RHS. Cosecant A is nothing but 1 by sin A. Cot A is nothing but cos A by sin A. Observe in RHS by sin A something there. So what I am going to do here? Let me divide numerator and denominator by sin A. Divide sin A for numerator and denominator. Split the terms and divide. Cos A by sin A minus sin A by sin A plus 1 by sin A. This is only for the numerator. Now denominator, cos A by sin A plus sin A by sin A minus 1 by sin A. Right? Cos A by sin A is nothing but cot A minus sin A cancel, 1 will be left, plus 1 by sin A is cosecant A divided by cos A by sin A is cot A plus sin A cancel, 1 minus 1 by sin A is cosecant A. What I can do now? Let me write minus 1 this side. That means cot A plus cosecant A minus 1 by cot A plus 1 minus cosecant A. Right? This is very important point you need to remember here. Now what I am going to do? Instead of 1, I am going to write something. By using identity, what is cosecant square A minus cot square A, that is 1, right? If you send this cot square A this side, minus cot square A, that equal to 1. Now, in place of 1, substitute this one. Okay, cot A plus cosecant A, let me take this in brackets, minus cosecant square A minus cot square A whole divided by cot A plus 1 minus cosecant A. Right? Again, this is in which form? It is in the form of A square minus B square. Split and write cot A plus cosecant A minus cosecant A plus cot A plus B into cosecant A minus cot A. Okay, A square minus B square can be written as A plus B into A minus B whole divided by cot A plus 1 minus cosecant A. Okay, now it's very easy. Observe in these two children, is there anything common? This set is common, so take out common. Cot A plus cosecant A, take out common. So here if I take full set common, 1 will be left minus, what is left there with a bracket you take? Cosecant A minus cot A by cot A plus 1 minus cosecant A. Okay, now remove brackets there. Cot A plus cosecant A into 1 minus cosecant A minus into minus plus cot A divided by cot A plus 1 minus cosecant A. Now observe here, cot A plus 1 minus cosecant A. Same you have, numerator and denominator cancel. So you are left with cot A plus cosecant A. Observe RHS. What is your RHS? Cosecant A plus cot A. Same you got. Therefore, this is equal to RHS. LHS is equal to RHS. Rewrite the question and say hence it is proved. See this problem and what we have done before. Two problems are little lengthy but they are very easy. Practice carefully, listen one more time and then do the problem. Okay. Sixth problem, square root of 1 plus sin A by 1 minus sin A equal to secant A plus tan A. Consider LHS. Square root of 1 plus sin A by 1 minus sin A. How we are going to do? Just extend the square root, multiply conjugate of the denominator. What is the conjugate of the denominator? 1 minus sin A. Conjugate is 1 plus sin A. Multiply for numerator and also denominator. One more step you write this, children. First you take LHS part first and then multiply conjugate of the denominator for numerator and denominator. Now inside the root, numerators multiply 1 plus sin A into 1 plus sin A by 1 minus sin A into 1 plus sin A. Okay. So now square root of A plus B into A plus B form there. So I will take it as 1 plus sin A whole square. And now here A minus B into A plus B. A square minus B square. Okay. Now square root of 1 plus sin A whole square as it is you keep there. Now denominator 1 square is 1. 1 minus sin square A you are going to get. What is 1 minus sin square A? 1 minus sin square A by identity. What I can write? 1 minus sine square a is nothing but cos square a. Write that one. Square root of 1 plus sine a whole square by cos square a. Now whole square, write full set. 1 plus sine a by cos a whole square. This square root cancels. 1 plus sine a by cos a. What is your RHS? Something there. So split this cos a to the two terms. 1 by cos a plus sine a by cos a. 1 by cos a is secant a and sine a by cos a is tan a. Observe the RHS, secant a plus tan a. So same you are going to get is equal to RHS. Therefore rewrite the question and say hence it is proved. Okay. So see the 7th problem. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equal to tan theta. Consider LHS. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. Okay. In numerator, is there anything common? Sin theta is common. Denominator, cos theta is common. Take out. Sin theta, if I take out common, nothing is left. That is 1 minus 2. 3 sin theta are there. If you take 1 common, you are left with sin square theta by, take out cos theta common. Here itself, 1 cos theta if you remove, you are going to get 2 cos square theta minus 1. Okay. Sin theta by cos theta is enough to get the answer. But what about other terms what you have? So think carefully. Sin theta into 1 minus 2 into, instead of sin square theta I can write it as 1 minus cos square theta. Substitute here. 1 minus cos square theta by cos theta into 2 cos square theta minus 1. Now remove this brackets. Sin theta into 1 minus 2 into 1 is 2, minus into minus plus 2 into cos square theta is 2 cos square theta by cos theta into 2 cos square theta minus 1. Now the same thing, what happens here? Sin theta by sin theta into 1 minus 2 will be minus 1. So I'll write here 2 cos square theta minus 1 by cos theta into 2 cos square theta minus 1. This set and this one cancel. You are left with sin theta by cos theta. That is tan theta. Therefore, this is equal to RHS. LHS is equal to RHS. Rewrite the question and say hence it is proved. 8th problem. Sin a plus cosec a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. Same manner consider left hand side LHS part, that is sin a plus cosecant a whole square plus cos a plus secant a whole square. Now you can see a plus b whole square, a plus b whole square. Right, what is a plus b whole square? That is a square plus 2ab plus b square. Apply this identity here. Here a value is sin a, b value is cosecant a. Sin square a plus 2 sin a into cosecant a, right, plus b square cosecant square a plus again a plus b whole square formula, that is cos A plus secant A whole square, right? A value is cos A, B value is secant A. That is cos square A plus 2 cos A into secant A plus secant square A. Sin square A plus cos square A is what? 1. We know that, write it. Okay. 1 plus 2 sin A cosecant A. I can write it as 1 by sin A plus cosecant square A plus, don't write cos square A, already sin square theta plus cos square theta is 1, we have written there, plus 2 cos A, secant A is nothing but 1 by cos A plus secant square A. Cos A cancel, sin A cancel. 1 plus 2, 3, 3 plus 2, 5. 5 plus cosecant square A plus secant square A. I didn't get RHS. So something I need to do. Do you remember the identities? What is cosecant square A? That is 1 plus cot square A. And what is secant square A? 1 plus tan square A. Now 5 plus 1 6, 6 plus 1 is 7. 7 plus tan square A plus cot square A. That's it. LHS is equal to RHS. Rewrite the question. Hence it is proved. This problem is very important. This question arrived in your model question paper also this year. Ninth problem. Cosecant A minus sin A into secant A minus cos A is equal to 1 by tan A plus cot A. Solve LHS separately and RHS separately given. So let us do. Consider left hand side. Cosecant A minus sin A into secant A minus cos A. Cosecant A can be written as 1 by sin A minus sin A. Secant A can be written as 1 by cos A minus cos A. Okay, do LCM. 1 minus sin A. You have here 1, so multiply sin A here. Sin A into sin A will be sin square A. Here also LCM is cos A. Cos A and 1 LCM is cos A. 1 minus cos square A. One more cos A, multiply here by identities. 1 minus sin square theta is cos square theta. So here 1 minus sin square A is cos square A by sin A into, what is 1 minus cos square A? Sin square A by cos A. 1 sin A cancel. 1 cos A will be cancelled. So you are left with cos A into sin A. Mark this first equation. Now consider RHS. What is your right hand side? 1 by tan A plus cot A. 1 by tan A can be written as sin A by cos A plus cot A can be written as cos A by sin A. Okay. Now denominator do LCM. Cos A into sin A. And now here in denominator cos A you have sin A is missing, multiply. Sin A into sin A is sin square A plus sin A you have in the denominator. So cos A multiply for the numerator. Cos square A. 1 by sin square A plus cos square A is 1 by cos A sin A. So bring this reciprocal and multiply for 1, that is cos A into sin A. So observe carefully, both are same. LHS is equal to RHS. Therefore, rewrite the question and say hence it is proved. And coming to your last problem in this chapter, 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan A by 1 minus cot A whole square is equal to tan square A. So you have three terms here. So what I will do first, let me consider this one. 1 plus tan square A by 1 plus cot square A. We know by identity 1 plus tan square A is secant square A and 1 plus cot square A is cosecant square A. Right? Now secant square A, again you write it as 1 by cos square A. Cosecant square A you can write it as 1 by sin square A. 1 by sin square A, do reverse and then multiply. You are going to get sin square A by cos square A. That is none other than tan square A. Sin A by cos A whole square, that is tan square A. Directly you can write. See, tan square A means this one you got equal. So let us take this one, consider this set. 1 minus tan A by 1 minus cot A whole square. Okay. So tan A is nothing but sin A by cos A divided by 1 minus cot A is cos A by sin A whole square. Okay. Do LCM. Cos A minus sin A by cos A divided by, again do here LCM. Sin A minus cos A by sin A whole square. Okay. Now bring this fraction to the numerator. Do the reciprocal and multiply. Cos A minus sin A by cos A into sin A by sin A minus cos A whole square. Now how can I prove? Before two problems we have done this one changes. What is that change? If you have cos A minus sin A, I think this also we can write it as cos A minus sin A. How? Take a negative sign common. If you take a negative sign common, what happens? Let me take negative here common. Plus sin A becomes minus sin A. And minus cos A becomes plus cos A. Now this one will be cancelled. You are left with minus sin A by cos A is tan A whole square. Minus into minus plus tan A whole square is tan square A. So observe here, this one we got tan square A, this one also we got tan square A, and this one also tan square A. Therefore all the three are equal, hence it is proved. With this, we are going to complete our exercise 8.3. Not only exercise 8.3, complete introduction to trigonometry is completed. Okay. So children, do practice carefully and don't forget to share your friends about the revision with Radhika ma'am. Okay. In our next video, we are going to meet with another new chapter. Until that, keep watching. Thank you all.